My name is Dr. Natalie Hicks. I'm a senior lecturer in marine biogeochemistry, and my research is understanding the role that oceans, predominantly sediments, play in global carbon cycling. Offshore wind farms play a big role in our marine environment, not only providing renewable energy, but they also change what happens on the seabed. So as soon as you put a structure like a wind farm in a sort of sandy or muddy area, you create a hard surface for different organisms to stick to. So often we see a load of different species start to congregate, and we get what we call an artificial reef effect on these structures, which is very different to any biodiversity we might have in the seabed itself. And so we see an increase in biodiversity around these seabeds. We don't yet know what that means for carbon cycling. We think there might be an increase in some of the carbon because of the presence and the active carbon cycling of these new organisms. And this might see a change or an increase in carbon in the seabed itself. One of the surprising positive impacts is this increase in biodiversity, and this makes us think about what we do when it comes to decommissioning. Under current legislation, anything that's been put in the marine environment must be removed when it's no longer useful, and this is something we're looking at now. As soon as you remove a structure like this, you then remove all that biodiversity too. Working with the seabed can be challenging. It's not particularly easy to access, and so often we require access to a research vessel or an industry vessel, a boat of some sort, to go to sea. And we use different equipment to effectively bring the seafloor back up to us. And we'll do this in a way that samples the seabed and brings it back to us intact. And then what we tend to do is we subsample that. So we take what might look like a drain pipe length of the seabed itself, and we'll often slice that up so we can look at the total carbon in those different slices. And then we run a whole load of other measures to understand the source of that carbon, where it's come from, perhaps the age of it, looking at the type of sediment too. And that helps us to build a picture around what the carbon is, how much is there, and maybe thinking about what some of those impacts might be that might impact the carbon storage potential of the seabed. It's really important to understand the role of the seabed and carbon cycling as it feeds directly into climate mitigation. So understanding how much carbon is in the seabed is important, but also understanding its vulnerability and how that might change with different human activities such as installation of energy structures or fisheries, and how best to protect that moving forward to help meet some of our net zero targets. It's really important that our science is not only addressing scientific questions, but links to policy as well. So for the carbon cycling work, we like to understand where some of our carbon stores are and what they might be vulnerable to, and working with partners like CFAS, who work directly with DEFRA and the government, we can help to ensure that any of our science informs future policy. A change of policy for renewables and energy. I think I would like to see an inclusion in carbon in a lot of our monitoring programs. At the moment, we've got a pretty good handle on biodiversity, but carbon's not considered at all. So if we could make that change and start to monitor and measure carbon alongside our other monitoring programs, that would be a huge step for us in terms of our knowledge. I didn't realise marine biogeochemistry was a field in itself, and so I did a degree in zoology. I was trying to keep my options as broad as possible, and so by the end of my final year I was deciding between marine benthic science and parasitology. I went the marine route in the end. Biogeochemistry is a brilliant discipline to work in because it integrates parts of biology, geology, chemistry, and it allows us to really understand what's happening in the marine environment as a consequence of all the interactions of those three different things. And so it's quite a strange thing. You don't really get a degree in biogeochemistry, but it's bringing backgrounds from all of those elements together as a way of understanding the marine environment. I think really understanding how much carbon we have in our sediments was very groundbreaking for us. And that's flagged up a huge number of questions in our lack of understanding of how long it's been there and how vulnerable it is. And so that's led to me really focusing on understand not only what's there, but how human interactions with it are important. And I guess my research has become a lot more collaborative, working with industry and policy as well to ensure that the impact is outside of the academic sphere. Keep an eye on the news, keep up to date with what's happening, look locally, see if there's any initiatives you can be involved with, and if you're at university and someone's research is really interesting to you, don't be shy to go and speak to them and find out a little bit more, and perhaps you can help them. I think the key skills, and you improve these as you go through your career, is adaptability, flexibility, and being open-minded. Things change quickly in science, and you might have a really set idea or methodology that you want to follow. It might not be feasible, it might not be logistically achievable, so being able to think about other options and overcoming those barriers is the biggest thing. Just keep staying focused and keep looking at other paths. There are so many unexplored areas of marine science. I think we know more about space than we do about the ocean. So there's constantly increasing areas of research that come up that we don't know anything about. I would obviously say the sediments are really important, we don't know a huge about. The deep sea is another area we don't know a lot about. And we're now looking at things like deep sea mining or further offshore exploration. And so really understanding these ecosystems is increasingly important. In my personal and professional opinion, I think anything that has sediments in is really important for climate change. We've talked about subtidal sediments quite a lot, so what's on our continental shelf, for example, in the North Sea. But moving closer to land, our coastal habitats are also really important. Things like salt marshes, which we have a lot of in the UK, play a huge role in taking up and storing carbon. So really understanding how they might change under different human pressures and with climate change is really important. This is one of the big priorities for expanding renewable energy. So really understanding the systems where we're putting offshore wind in. We already work quite closely with different offshore companies, and they are also keen to ensure that any future growth is sustainable and environmentally friendly. So making sure we continue to do research along that lines is really important. Unlimited resources. I could roll up a really large monitoring program. We can really dig into understanding the different sediments and the interactions. We could work a lot more closely with industry. We could also recruit the next generation of scientists, and I think that is where our future really stands. Bringing young people on board, training them up in these skills and sending them out to work in research, industry and policy. Hopefully still relevant and interesting. I don't see my interest changing. I think we're going to see a lot more about seabed and carbon in the future, and so in 5 years' time I'll still be working on the same themes. I wish people realize that it's not always the big, really amazing animals that play an important role, and many people come into marine science because they're interested in whales or sharks or dolphins, which are important organisms for marine ecosystem, but actually understanding the habitats that they are in and things like sediments play a really huge role. So it's good to have those what I call gateway organisms to discover marine science, and then hopefully as students study with us we open their minds to all the other possibilities.